sun up on Mars, the dusty red planet. Mars is fascinating, for it's the world on which next we'll tread. It's little over half the size of Earth, but there's much in common. Mars has an atmosphere, seasons, and a day of 24.5 hours. But the red planet is bitterly cold, at best just above freezing. The Sun is at an average distance of 228 million kilometers. One solar orbit takes 687 days. Mars setting behind one of its two tiny moons. They're probably ancient asteroids, petrified rocks captured by an ice-cool planet. Like Earth, Mars has a tilted axis. That and its elliptical orbit distort the seasons. Farthest from the Sun, it's summer in the northern hemisphere and winter in the south. Closest to the Sun, and it's winter in the north and summer in the south. At the North Pole, the ice cap grows in the short, relatively mild northern winter. It shrinks in the long, relatively cool northern summer. At the other pole, the southern ice cap grows much bigger. Compared to the north, winter in the south is long and severe. But the southern summer is short and less cool than summer in the north. Geologically, Mars has a divide. To the south, older cratered terrain. To the north, younger lava plains. The first close-ups are from the 1960s. They're flybys of the early Mariner missions. This picture of dark spots in a dust storm is clarified later as 4 huge volcanic peaks. For when dust storms kick up on Mars, they can last for weeks and envelop the planet. In 1976, orbiters called Viking revolutionize our understanding of Mars. They hint at subsurface ice. Did the impact that gouged this crater spill melt ice over the rim? As this flood channel testifies, water once flowed on Mars. An ancient island. The Vikings photographed frost and early morning fog. And the notorious face on Mars, just a trick of light. (1976), the Viking landers. 2 robots dig for signs of Martian life. But nothing stirs. For an idea of scale, superimpose North America on Mars. The distance from coast to coast is some 4,000 kilometers. That's the length of the red planet's greatest rift, Mariner Valley. We take a second look, but from closer to the surface. Skimming the craters of the southern hemisphere, we turn west to fly the largest geological fault in the solar system, Mariner Valley. to the highlands west of Mariner and the volcanic dome of Arsia. Another called Pavonis. A third named Ascrius. But this is the volcanic peak that tops them all, Olympus Mons. Rising 27 kilometers, Olympus Mons is 3 times the height of Mount Everest. These cliffs alone are 6 kilometers high. Olympus Mons is the biggest volcanic peak in the solar system. There's a theory of oceans forming on early Mars because of immense volcanic upheaval. Eruptions melt subsurface ice, quickly flooding the planet. A respectable atmosphere develops of carbon dioxide. Temperatures soar, so why doesn't Mars go green and spark life? One factor could be climatic instability caused by huge variations in the tilt of the planet. But the main reason is volcanic shutdown. No major eruptions to replenish the atmosphere. An atmosphere slowly leaking into space because of weak Martian gravity. Mars Pathfinder. In 1997, it sets down on an old flash flood plain. It trundles out a robot rover to analyze the composition of the rocks, with intriguing results. Apparently carried on great surges of water, the rocks are quite diverse. Some are volcanic, similar to those formed in oceans on Earth. Was this once a floodbed leading to a Martian ocean? Supporting evidence from orbit with the Mars Global Surveyor. Charged with mapping the planet in unprecedented detail, Surveyor scans a huge flat region in the northern hemisphere. It has all the characteristics of an ocean floor. By contrast to that watery epoch, today's Mars is a freezing desert, retaining not a drop of liquid water. But Mars does have the vestige of a magnetic field. It's measured by Global Surveyor. Destination Mars. With the success of Pathfinder and Global Surveyor, regular twin missions are planned, each with a lander and an orbiter. Known as the Mars Surveyor program, the objective is to understand the story of water on the planet. Many scientists believe it abounds there, locked up as ice beneath the surface. The orbiter is to trace flood channels and in false color map the geology. Meanwhile, the lander streaks through the Martian atmosphere, 150 times thinner than our air on Earth. On the surface, it continues the hunt for life. Could microbes survive here, bereft of warmth and water? And could we? Is this dusty world a place for human beings? Only time and the robots will tell.